In Module 1, we're going to be talking about functions, covariation, and calculus triangles. Function type 1. For context, we're going to look at 3 different jobs for Chandler-Gilbert Community College. Technology Support Specialist Senior, with an hourly wage ranging from $23.17 up to $30.12, full-time. Custodian, with an hourly wage of $18.82 per hour, part-time. And Maintenance Operations Specialist, with an hourly wage range from $20.23 per hour up to $26.30 per hour, also full-time. Your learning task is to represent the maximum hourly wage of a job as a function of the number of hours worked weekly. And you're to do that with a graph, with a table, with an equation, and with words. The maximum number of hours for full-time jobs is 40 hours. And for part-time jobs is 25 hours. What type of a function is this? What is the general form of such a function? And for a 1-unit change in the input value, describe the corresponding change in the output value. Pause the video and complete the learning task before continuing. I start out by defining my variables. Let H be the number of hours worked and W be the hourly wage. I next draw the graph, with the horizontal axis representing H, hours worked, and the vertical axis representing W, the hourly wage. I know that the hourly wage does not change. It's always $30.12. So you see there I drew a horizontal line at $30.12, all the way up to 25 hours. Now I graph the function for a part-time job. The same sort of reasoning would apply for the full-time job. Similarly, I created the table. We can see that no matter the number of hours, the wage is always $30.12. The equation is W equals 3012. It does not depend on H because W is constant. And finally, in words, the hourly wage W is a constant, $30.12 for all hours worked. This is a constant function. A constant function has the form y equals c. A 1-unit change in the input value does not have any effect on the output value. The output value is constant. It never changes. Your next task is to engage in a learning reflection. In your notes for your future forgetful self, record the general form of a constant function and note how a 1-unit increase in input affects the output. Take time to record your reflection now. Pause the video. Complete the learning reflection before continuing. We will now move on to function type 2. Let's begin with a context. Pyrite crystals. Pyrite crystals are often cubical or near cubical. A perfect cube has equal length, width, and height. Naturally occurring pyrite cubes have been known to reach up to 25 centimeters per side. Our first learning task is to represent the area of a face of a cubic pyrite crystal as a function of its side length. Then we are to represent the volume of the crystal as a function of its side length. We're to do this with a graph, a table, an equation, and with words. What type of function are the area and volume functions? What is the general form of such a function? The general form should work for both functions. Pause the video and complete the learning task before continuing. We begin by defining our variables. We let S be the side length, measured in centimeters, and A be the area of a face, measured in square centimeters. We can see the equation would be A is equal to S squared. The area A is the square of the side length S. We generate a table of values with various values of S ranging from 1 to 7, and calculate the value of A by squaring that value of S. And finally, we graph the function. This is a power function. A power function has the form f of x equals x to the b, where b is some constant value. For the second part of the learning task, we calculate the volume. Once again, we define the variables. Let S be the side length in centimeters, and V be the volume in cubic centimeters. The volume, V, is the cube of the side length S, or as an equation, v equal s cubed. We then calculate the values of v based on various values of s. Finally, we graph the function. This is also a power function. Power function has the form f of x equals x to the b, where b is a constant value. Learning task 2 builds upon learning task 1. We are to create a table of values for the area, A, and volume, V, using side length S equal to 1, 2, 3, 4, 5, 6, and 7 centimeters. We are then to add a third column to each table and calculate delta A and delta V, that is, the change in A and the change in V. On the area graph created in task 1, we're to represent delta S and delta A graphically in calculus triangles. What patterns, if any, do you observe in delta A? On the volume graph created in task 1, we're to represent delta S and delta V graphically in calculus triangles. What patterns, if any, do you observe in delta V? Recall that a calculus triangle is a right triangle with height delta y and base delta x. So we start by calculating the change in x. That becomes the horizontal leg of this right triangle. And then we calculate delta y, which is the change in the y values, y2 minus y1. And we calculate the vertical change, and then we draw that on the graph. It's customary we don't draw the hypotenuse between those 2 points, but you could if you wanted to, but oftentimes you can see what you need to see just from the horizontal and vertical legs. Pause the video and complete the learning task before continuing. We begin the learning task by calculating delta A. So I'm looking first of all for the change between the area of 4 and 1. 4 minus 1 is 3, so I get that delta A between 1 and 2 centimeters is 3. Next, I calculate the change between 9 and 4. Because 9 minus 4 is 5, the change in A between 2 and 3 is 5, and so on. I repeat on down the line. I observe that the values of delta A are increasing by 2 square centimeters for each additional centimeter of side length. When the side length increases from 1 to 2 centimeters, the area increases by 3 square centimeters. When the side length increases from 2 to 3 centimeters, the area increases by 5 square centimeters. When the side length increases from 3 to 4, the area increases by 7 square centimeters, and so on. I go over to the graph and draw in the horizontal and the vertical changes. The horizontal changes are all equal to 1, and the vertical changes are 3, 5, 7, 9, 11, and 13, respectively. We begin by calculating delta V. Between 1 and 2 centimeters, the change in V is equal to 8 minus 1, which equals 7 cubic centimeters. For 2 and 3 centimeters, delta V is 27 minus 8. We get the 19 cubic centimeters, and so on down the line. The values of delta V are increasing. When the side length increases from 1 to 2 centimeters, the volume increases by 7 cubic centimeters. However, when the side length increases from 6 to 7 centimeters, the volume increases by 127 cubic centimeters. We go to the graph and draw the calculus triangles. All of the calculus triangles have base equal to 1 centimeter. The height of the triangle varies based on the values in the table. And we can see that those heights are increasing as we draw them. In your notes for your future forgetful self, record the general form of a power function. When the initial value is 1, like the examples we looked at, and also when the initial value is some constant A. Describe what a calculus triangle represents, and then create a power function graph and draw and label the corresponding calculus triangles. Pause the video and complete the learning reflection before continuing. Function type 3. Zach King's broomstick ride TikTok video went viral, racking up 2.3 billion views as of June 2025. It is said to be the most watched TikTok video ever. The Fast Track Girl, Kiara Butcher, is a local entrepreneur who generates income by marketing consumer products on TikTok. Her viral video promoting a stand-up desk received 24 million views, generated $500,000 plus in sales, and $50,000 plus in commissions in 30 days. We are going to model a viral TikTok video. We're going to start with a few basic assumptions. First of all, that the model is valid for up to 10 hop counts. In a sharing network, the hop count measures how many steps or shares separate a person from the original creator. The creator is at hop count 0. Someone who receives the video directly from the creator is at hop count 1. And someone who receives it from them is at hop count 2, and so on. Each person who receives the video link will share the link with 4 other people. Learning task 1. A creator shares the original video link with her 4 closest friends. Represent the views as a function of hop count, with a graph, with a table, with an equation, and with words. Note, we are not looking for total views at this stage. We are looking for the number of views that occur at each hop count. What type of function is this? And what is a general form of this type of function? Pause the video and complete the learning task before continuing. We begin by defining our variables. Let h represent the hop count and v represent the number of views at that hop count. The creator shares the link with 4 people, so at hop count 1, 4 people will watch the video. Each hop count 1 viewer will share it with 4 people, so at hop count 2, 16 people will watch the video. Each hop count 2 viewer will share it with 4 people, so at hop count 3, 64 people will watch the video. Each hop count 3 viewer will share it with 4 people, so at hop count 4, 256 people will watch the video. We record the values in the table. We observe that v is equal to 4 to the h. That is, the number of views v is a function of the number of hops. For each 1 unit increase in hops, the number of views increases by 4 times. That is, the number of views at any hop is 4 times greater than the hop before it. This is an exponential function. When the initial value is 1, an exponential function has a general form of f of x equal b to the x. We also represent this graphically. You can see how rapidly the views increases as the hop count increases. In your notes for your future forgetful self, record the general form of an exponential function when the initial value is 1, as in our example, and when the initial value is a constant. Create 2 exponential function examples. The first example should have increasing output values, and the second example should have decreasing output values. Each function should be represented with a graph, a table, an equation, and in words. Pause the video and complete the learning reflection before continuing.